You are writing code, and you have to choose Claude or GPT. In 2026, that decision actually matters more than it did a year ago because both models have made significant jumps, and they have jumped in different directions. This video shows you exactly which one wins for coding and when. To be clear up front, this is not a marketing piece for either company. We ran both models through the same tasks, in the same environment with the same prompts. No cherry picking. The results surprised us in a few places, and we are showing you all of it. Before we get into results, let us be clear about how we structured these tests. We used 3 categories that reflect real developer work: writing new code from a plain English prompt, debugging broken code, and navigating a large codebase. Each category had 10 separate tasks. We tested across 4 languages: Python, TypeScript, Rust, and SQL. We used the latest available API versions for both models as of mid-2026. We measured correctness, whether the code ran without errors, and code quality, meaning readability, security, and adherence to standard patterns. The first category is generating new functions from a plain English prompt. Something like, write a Python function that takes a list of user objects and returns only those whose subscription is active and who have logged in within the last 30 days. Simple but representative. On code generation, Claude consistently produced more defensive code. It added input validation, handled edge cases like empty lists, and wrote docstrings without being asked. GPT produced shorter code that ran correctly, but often skipped the defensive layers. For production code, that difference is not small. GPT was faster at getting to a working first draft. If you just need something that runs and you plan to review it yourself, GPT gets you there in fewer tokens. Claude was slower in some runs, but the output needed fewer follow-up corrections. It depends on whether your bottleneck is reading or rewriting. Now we hand both models the same broken code and see who fixes it. The bugs ranged from a simple off-by-1 error in a loop to a race condition in an async function to a subtle SQL injection vulnerability hiding inside a string format call. Claude caught the SQL injection vulnerability in every test. GPT caught it in 6 out of 10 runs, and in the other 4 it rewrote the function correctly, but did not flag the security issue by name. For security-sensitive code, that is a meaningful gap. On the race condition, both models struggled. Claude explained the problem clearly, but its proposed fix introduced a second issue in 3 cases. GPT fixed the async logic correctly more often, but gave a shorter explanation. If you are learning as you go, Claude's explanation is more useful even when the fix needs another pass. This is where context length becomes the deciding factor. We fed both models a file set totaling around 80,000 tokens of a real open-source project and asked questions that required understanding relationships across multiple files. This is where the comparison got very interesting. Claude maintained context accuracy significantly better across long inputs. When we asked it to find all the places a specific function was called and explain how each call site handled the return value, it tracked 7 of 8 correctly. GPT tracked 4 of 8 and hallucinated 2 call sites that did not exist in the codebase. Hallucination in code is expensive. If GPT tells you a function is called in a file and you spend 20 minutes looking for it, that is a real cost. Claude's advantage in long context accuracy has a direct dollar value for anyone doing code review or refactoring on a large project. The language you use changes which model has the edge. In Python and TypeScript, the gap between Claude and GPT is relatively small. In Rust, Claude was noticeably better, producing idiomatic code that used ownership and borrowing correctly far more often. GPT's Rust output compiled but frequently used patterns that experienced Rust developers would flag in review. For SQL, GPT held its own and in some cases wrote more optimized queries. Claude's SQL was correct, but GPT seemed to have a stronger intuition for query performance, using indexes and avoiding full table scans more reliably across the test cases. Speed and API pricing are the final piece of this picture. As of mid-2026, the cost per million output tokens differs between the two models, and that gap matters at scale. If you are running thousands of code generation calls per day, a 20% cost difference is real money. We link the current pricing pages in the description so you can check the latest numbers. Response latency also varies. In our tests, GPT returned first tokens faster on average. For interactive coding assistance inside an IDE, that latency shows up as a noticeable field difference. Claude felt slightly slower in streaming, but the output required fewer follow-up prompts, which in practice balanced out the total time to a working solution. So, which model should you actually use? The honest answer is, it depends on your task, but there is a clear pattern. If you are doing greenfield development, writing new services, or working in Rust, Claude is the stronger daily driver. If you are doing rapid prototyping, SQL work, or you need fast interactive responses in an IDE, GPT has the edge. For teams working on security-sensitive code or doing large codebase refactors, Claude's accuracy advantage at long context and its tendency to flag vulnerabilities make it the safer choice. The cost of a missed security issue is higher than the cost of a slightly higher token price. Neither model is perfect. Both will still write bugs, miss edge cases, and occasionally hallucinate APIs that do not exist. Treating either one as a replacement for code review is a mistake. The developers getting the most out of these tools use them as a first draft engine and apply their own judgment at every step. If this breakdown was useful, hit the like button and subscribe. Next week, we are going deeper on AI coding agents, the tools that go beyond chat and actually run your code, write tests, and open pull requests autonomously. That video will change how you think about what AI can do in a real development workflow.